Record started. Okay, so yesterday we left in between using ultrasonic sensor. So today we'll be continuing that. Yesterday we did small mistake. So the sensor reading was showing as zeros, right? Wait, I'm going to my Tinkercad. Oh, screen sharing. I didn't do that. Okay, share. Yeah, is my screen visible? Hello.
Yeah, your screen is visible.
Okay. Hmm. Okay, fine. We'll start today with this ultrasonic sensor. Yesterday we left in right in the last class, so we are continuing that. Think of this. Okay.
ಬಗ್ಗೆ ನೋಡಿದ್ಯಾ robotics ಬಗ್ಗೆ ನೋಡಿ CAT ಹೆಲ್ಪ್ ಆಗತ್ತೆ ಬಾಯ್ಲಿ
CET ಇದಕ್ಕೆ ಹೆಂಗ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ? Okay, where is the calculations thing? Yeah. So we'll take this image and I'll explain a bit about this ultrasonic sensor. Yesterday I didn't explain properly, so oh, this is a video. Where is that image? Yeah. It's taking time to load. Please mute. Someone is on here. Please mute yourself. Shreyas. Okay. My screen is visible, right? I'm audible. Yes or no?
Yes, bro.
Yeah. So this is the ultrasonic sensor. Yesterday I was explaining this only. One circle is transmitter, one is receiver. So whenever you trigger, you give a pulse to trigger, it will transmit this wave signal in this form. And whenever there is an object in front of that waves, the waves will rebound back and reach to the receiver. So duration of this, like transmission and receiver, we will read in the echo. Like if the signal is traveling for 2 seconds, so if you read the echo pin, you will get 2 seconds as the reading. So to read that, we have a function called as a pulse in to read the pulse coming in. So yesterday we have written some code. Here, what was the mistake is, one second, I'll start the simulation. Yeah. So okay, I have changed it. Yesterday, actually, I like to demonstrate, I had connected this to 3.3 volts. So the sensor is powered up with 3.3 volts. If this sensor requires 5 volts. If it is triggered with 3.3 volts, it doesn't work. So if I open my serial monitor, it shows 0. You can see it is coming 0. This 265, it is yesterday's reading. I mean, now I simulated, right? So it is showing 255, 265. So now I'm getting 0 because I have not powered it properly. The sensor should be powered with 5 volts, but I have given only 3.3 volts. You can see the multimeter here, it is showing 3.3 volts. So we have to power this sensor with 5 volts. I'll change my wire to 5 volts. Now if I simulate, I'll explain the code once again. So you can see I'm getting a reading as 265. So this is in terms of centimeter. So you can see here it is 269. Here it is 269. It depends on the calculation you do. Sometimes it will be like precision bit differs from the original thing. So if I get this object closer, you can see the reading is going 104. Here it is showing 106 on the sensor. So it is almost yeah, like nearby value, so it doesn't affect. By doing this calculation, we are getting that value. If I do, like, there are 2 to 3 different types of calculation. Every concept is same, but we can write this like 0.034. Instead of multiplying with duration, we can divide it. Like 1 by 0.034 will give me 29. So I can, okay, I'll stop this. I can divide, like, 1 by 0.034 will give me 29, right? So divide by 29. So this is also will give me the same readings. It depends on how you calculate. So it is giving like much more better value. Like nearby, it is 87.7. I'm getting 87. So now we'll once again look into the code what you have written yesterday. I'll close the serial monitor. So we know how the trigger pin is working and echo pin is working. Everyone knows, right? There is any doubt with this, like what is trigger pin and echo pin in the sensor? If anyone has this doubt, you can ask, or can we continue? Respond. Hello. Hello.
ಹಲೋ ಮಗ, ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿದ್ಯಾ?
ಹೌದು, ಆಗಿದೆಯಲ್ಲ, ಬರ್ಲಿಲ್ವಾ?
ನನಗೆ ಬ್ಲಾಂಕ್ ಆಗಿದೆ.
Is my screen visible?
Yes.
Yes ಅಂತಿದ್ದಾರೆ. I'll stop the share and I'll restart my screen share. Yeah, now you can check. Is it visible? Have very ಕಾಣಿಸ್ತಿದ್ಯಾ? Yeah, so this is serial monitor is like checking for outputs of the, like if you normally write C programming or any programming, you will just check the output window, right? So in this Arduino, we have something called a serial monitor. You should match those things with this baud rate. You should use proper baud rate, and you should use the serial monitor with that baud rate only to see the proper values. If you give some other baud rate and like in serial monitor, in this we don't have option. If you go to Arduino, ideally you can change the baud rate of serial monitor which you are reading. Both should match, then only you can read the proper readings. So I'll explain this code for the ultrasonic sensor. So what we'll do is we should first generate sound waves. To generate a sound wave, we have to trigger this sensor. So what we are doing is we are like this in the loop. First we are declaring some variables, that is duration and centimeters. Duration is to check like sound wave is traveling for like how many duration it is traveling. Then centimeter is to convert the duration into centimeters. So then we have to generate the pulse. So to generate the pulse, what we are doing is we'll initially make the trigger pin low, then for 2 microseconds. Okay, then we are making it high. Whenever we make trigger pin high, it will start sending the waves. So for 5 microseconds, we are sending the waves. Then we are turning back it to low. So for every 5 microsecond, it will send a new set of signals, and that signal will strike some object and it will bounce back. So the bounce back signal will be reaching to the receiver, and it will, whenever it receives the signal, it will generate a echo, like echo signal. So we have to read that echo signal. To read that echo signal, we have declared the echo pin as input. Now we have something called as pulse in function. This function will calculate the like time in microseconds. That this function will take 2 parameters. One is pin and which one to read. Like if pin goes high, I should read, or if pin goes low, we have to read. So here, if the pin goes high, we have to start that readings. So I've given echo comma high. It means whenever the echo pin goes high, echo pins goes high when the signal is received, like bounce back signal is received. I mean the waves are received. So whenever it goes from low to high, the pulse in function will start the timer, and whenever it goes from high to low, it will stop the timer, and the duration, for how long it was like high, that is saved in the variable called as duration. So we got the duration of the like object, like how far it is, the sound wave is traveling for so many seconds. If it is too far, the sound wave will travel for more time and it will bounce back in more time, right? If it is too near, then it will bounce back very fast. So the duration will be very short. So we have to calculate the distance by duration. We know that sound wave will travel at speed of 340 meter per second. So, but here the pulse in function will read microseconds. So we have to convert that, and we need centimeters, right? Not meters. So what we'll do is we'll convert that meter per second to centimeter per microseconds. So for centimeter per microsecond, the value of 340 will become 0.034. Okay. So we'll multiply that duration, that time, like speed of time in microseconds per centimeter, to the duration which we are getting. And we will divide it by 2, because the sound wave will travel to the object and it will bounce back. So it is traveling twice, right? It is going to the object. We need only distance from sensor to the object, but the sound waves is going to the object and it is coming back. It means we have twice the duration of reaching the object. So we'll divide it by 2. And to see the readings, what we are doing is we'll use serial.print. If I use serial.print and that variable, what happens is, if I run the code, we have two functions, serial.println or print new line, we can say that as. Oh, okay, 1 second. So if I open my, see, it is going in a single line. The readings are going in single line. You can see it is going in a straight line, 135, 134. If I change the value, okay, like if I change the distance of the object, here I have the object. If I change this, it is going in a straight line, which is not readable, right? So we have to print every time in a new line. So to print each time in a new line, we have function called as serial.println, not just print. We have something called as println. So if we use println, what happens is every reading will go to new line. What happened? 1 second. Okay, I have paused here, like there is some stopper played. Okay, so now you can see it is showing 35. So it is printing in a new line. If I move the object far, the readings is getting changed. So now what we have the distance of the object. So now we can write some conditions so that we can control our car or something, like for whatever application we are using. So for now, what I will do is, if the like object is below like 20 to 30 centimeter, then my what I'll do, red LED will glow. Okay, if the object is less than 20 centimeters, I'll blow the red LED. If it is more than 20 centimeter, I'll blow the green LED. To do that, what we'll do is we'll use a if condition. If centimeter, right? So centimeter is less than or equal to 20. If it is less than or equal to 20, we have to turn on the red LED. So again, write digital write red LED. What I have declared for the red LED, I have declared as red LED only. So I'll take this thing. So red LED, comma, I'll make this as high. Okay. Oh, sorry. High should be capital. then I should make green LED low, because like if it is less than that, if it is greater than that, a green LED will high, right? So I should turn that off. So to make it off, I'll write that command, digital write. One second, I'll check what I mentioned here. Okay, green LED. So green LED comma low, so that the green LED will turn off and red LED will turn on. And we'll use else if that condition is not satisfied. Then what should happen? My green LED should be on and my red LED should be off. So I'll copy this code and paste. Then I should change this to low. My red LED should be low, then this green LED should be high. Okay, so I'll run my code. Okay, what did I do? Okay, right. Okay, see, now my green LED is glowing because the centimeter is 206. So if I go below 20, okay, and this below 20, see, you can see red LED is glowing now. Okay, we'll change this 20 to like I'll make it as some 50 centimeters, so that will be easy to show. So I'll make condition as if it is less than 50, my red LED should glow. So this is less. Okay, close the code. See, the red LED is glowing because it is less than 50 centimeters. If I go above 50 centimeters, now it is 68 centimeters, my green LED is glowing. If I go below 50, my red LED is glowing and my green LED is turned off. This is how you can use this object detection. And I have a buzzer also. If it is like object is very closer, I want to like beep the buzzer. So what I'll do is I'll use if else. Okay, so I can write many conditions. You know how if else work, right? If else sorry, else if, right? Not if else. Oh, else if centimeter is less than 30, if it is like below 30 centimeters, I'll turn my this with like with the red LED, I'll turn my buzzer also high. So I'll copy this thing. Okay, not this thing. I should keep this to else. So else so if it is less than 30 centimeter, what I should do is I should turn on my buzzer on. So even the red LED on. So I'll copy these things. My green LED is off, and I should make buzzer on, right? So I'll make digital write buzzer as high. So here buzzer. Okay, so buzzer is high. So everywhere I should write the conditions that here the buzzer should be low, right? So I have to mention buzzer to be low for this condition, and buzzer to be low at this condition also. So now if I like run my code, you can see like if it is less than 50, one second, I'll close this code. This is visible, right? Okay, so it is 140 centimeters. Now if I go less than 50, my red LED started glowing. If I go less than 30, okay, buzzer didn't get on. Why? One second, we'll check the code. Oh, what happened? If it is less than 30, okay, sorry, first I should write for less than 30. this condition is first, like in if statement we know that the first command will be executed first, then the second, like if that condition doesn't satisfy only it will come inside, right? So I'm writing 30 inside, so always like below 50 only 30 will come, so I have to change these conditions. So first I have to mention 30 to be there, like in the top. Then inside here I should mention 50. So first it will check it is 30. Okay. Uh, so if it is less than 50, it is not less than 50. Yeah. So now you can see it is less than 50. So my red LED is glowing. If I go less than 30, my buzzer and also red LED is glowing and buzzer is also coming. So if I go more than 50, my only green LED is glowing. So this is how you can use this sensor. So anyone is having any doubt, you can ask me. If no doubts, we'll continue with PIR sensor and class sensors. Any doubt with the sensor? This if statement, if anyone is having confusion. So why I changed this conditions was, like first every time if else ladder, this is an if else ladder, so first it will check for this condition. If this fails only, it will go to the next. If this condition is true, then it will never go to this or else. So before what I done is centimeter less than 50 it was. So if I write inside centimeters less than 30, obviously 30 is less than 50. So this like first condition will get satisfied, so it will never go to the second condition and my buzzer will never turn on. So I've changed the condition. This is like priority, giving which one priority more, like, so you should check the priority, then you should code in if else ladder. So any doubts? Hello. 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 I'm not able to hear you people. What happened? Hello.
ಹಲೋ
ಏನಾಯ್ತು?
ಏನಿಲ್ಲ,
ಕೇಳಿಸ್ತಿತ್ತಾ?
ಕೇಳಿಸ್ತಿದೆ.
ಮತ್ತೇನಾಯ್ತು? ಅವಾಗಿಂದ ಕೇಳ್ತೀನಿ. ಲೈಕ್ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ ಇಫ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಲ್ಲ, ಲೈಕ್ ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ದಿಸ್ ಫಂಕ್ಷನ್ಸ್ or how to calculate this duration of centimeters? If anyone is having doubt, you can raise them, so we'll solve that here. Clear Wasim?
ಮಗ ಇನ್ನೊಂದ್ಸಲಿ ಅದು ಕೋಡ್ ಒಂಚೂರು ಹಾಗೆ ಗ್ಲಾನ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ನೋಡು.
ಯಾವುದು ಲೈಕ್ ಯಾವ್ದ್ರ ಬಗ್ಗೆ, ಲೈಕ್ ಇಫ್ ಕಂಡೀಷನ್ ಬಗ್ಗೆನಾ ಇಲ್ಲ ಈ ಸೆನ್ಸರ್ ನ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು, ಡಿಸ್ಟೆನ್ಸ್ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು?
ಇಲ್ಲ, ಕೋಡ್ ಪೂರ್ತಿ ಹೇಗ್ ಬರ್ದಿದ್ಯಾ ಅದೊಂಚೂರು.
Okay, so this sensor is like sound sensor, like it will produce a sound wave and it will receive the sound wave. So to produce the sound wave, we have to send pulse, so that if this pin goes right, it will start producing the signals. Okay, so what I'm doing is I will trigger this pin for particular amount of time, so that it will send some packets of waves, not continuously sending. We'll send some packets of wave, we'll have a break, we'll send some like that. So what I'm doing is I'm making trigger pin low for 2 microseconds. Then we'll make for 5 microsecond high. So in this 5 microsecond it is high, right? Trigger pin goes high for 5 microsecond. So it can maximum generate up to 3 to 4 waves, I guess. So it will generate 3 to 4 waves. Then it will go low. Okay. These generated waves will travel until if it is having some obstacle in front of it, it will bounce back if it touches that. If it doesn't touch, it will be going wrongly. So somewhere you will be having some obstacle, it will bounce back, so it will receive. So whenever you receive the signal, this echo pin will go high. Whenever you receive the signal, echo pin will go high for that duration. So what you will do is you will read that pin, echo pin you should read, because the sensor will make this pin high. So you have to read that pin. To read the pin, we have to declare that pin as input pin. So I've declared in the pin mode as echo pin to be input. Now we have some function called as pulse in. If you want to know detail about the pulse in function, you can just type pulse in Arduino. If you type, right, you'll get this function in the arduino.cc, which is an official website. You can read like it is given what all parameter it takes, and like how, like you have some example codes to work to use this function, where you can use and how you can use. So this function is like, it will calculate the duration. You can see here, reads a pulse either high or low on a pin. So it will read either high or low. If the value is high, pulse in waits for the pin to go low to high and starts the timing. So as I told, if you are writing a pin, that echo pin comma high, it means you will only read when the pin will go high. Will start the timer whenever the pin goes high. So that function will wait the pin to go high. Whenever it toggles from low to high, the function will start the timer, and whenever it goes from high to low, it will stop the timer. So there you will get the duration in microseconds. You will get, okay. So that duration, what we are doing is we'll capture it in a variable. Where is this? Okay. So we are capturing using the pulse in function. We are capturing only the high, like for what amount of time that pin will go high. So that duration is captured in this variable. So this duration, we have to convert this duration into centimeters. So to convert that duration into centimeters, we know that, yeah, is someone is asking something? Nothing, right? Okay. So to convert the duration into centimeters, we know that sound wave travels 340 meters per second. So it is in meter per second. Here we need in centimeters, and the duration is in microseconds. So we have to convert that meter per second into centimeter per microseconds. So if you convert that meter per second into centimeter per microsecond, the value of 340 meter per second will become 0.034. So you will multiply this scaling factor to that duration, so that you will get the total duration which it is traveled. Then you will divide it by 2, because the waves go to the object and it will strike there and it will come back. So it will travel 2 times, right? It will go to the object. What we need is from sensor to the object. Only one path is enough. But what here happens is a wave will go, it will hit the object and it will come back. So we have 2 times the time it will, which is traveling. So we'll divide it by 2 to get the proper like distance in centimeters. So now we got the centimeters. We have captured that in the centimeters variable. So we'll write some if conditions, that if the centimeter is less than 30 centimeter, I'll blow buzzer so that it is very near, like some circuitry, some object is very near to it. I'll start a buzzer blowing to it. So I'll write digital write buzzer go high, and digital write LED pin to like red LED to go high and green LED to go low for indicating purpose. Then if there is like the object is far like 50 centimeters, some danger is there, but it is not that much danger. So what I'm doing is I'm just indicating with the red LED. I'm not like I'm stopping the buzzer because it is bit far. So I'm not using the buzzer here. And green LED is low, obviously. So we'll write digital write, and we'll turn the pins high and low. Else means if it is far from 50 centimeters, so it is safe zone for me. I feel that it is a safe zone. So what I'm doing is I'll turn on the green LED and I'll turn off the buzzers and red LEDs in case if it is on, like in like previous case, the buzzer may be on. So if suddenly it goes like above 50 centimeters, I should turn off, right? So it will directly come to this statement. So we have to mention the buzzer to also go off and also red LED to go off. This is what we are doing with the sensor. Any doubts now? We have 1 minute, like recording will stop. Sorry, session will end. Hello. Hello.
So, bro, the
Yeah.
signal, the process of signal sending from the sensor to the buzzer, it's done by echo, right?
Not to the
Overall,
buzzer.
like to the chip, and then chip is sending signal to the buzzer.
No. What we are doing here is we are just calculating the distance from the sensor. Like whatever sensor data it will give in microseconds. It will give seconds, how much seconds the wave have traveled. Okay. So that timing will convert it to centimeters. Like using the speed of sound will convert it. Then that centimeter will use it if statements and will use that. Like if it is less than 30 centimeter, will turn on buzzers and all. If it is less than, like if it is larger than 30 centimeter and below 50 centimeters, will only show the red LED glowing by using digital, right? Then if it is more than 50 centimeter, will show green LED indicating that it is safe, no issues with the objects, something like that. You can use
This
motor.
all will be done by triggers.
Trigger pin is to like generate the wave. Like from this sensor there is a transmitter and receiver. You should generate the waves, right? To generate the wave you will trigger the trigger pin, so that if the trigger pin goes high, it will generate the waves, and echo pin will read. It is a receiver. Echo pin means whenever it receives, it makes the pin go high, like okay guys, yeah, there was a limit reach, so I'll continue this thing. Where were we? Yeah. So the trigger pin, you people joined, right?
Yeah,
Uh,
bro. Continue. I'm not able to see your screen.
yeah,
Please
yeah.
share, bro.
I have to share the screen, so I'm just checking everyone has joined. Yeah, so everyone has joined. We'll start this. Yeah, so here trigger pin is to generate the wave, and echo pin is it goes high whenever it receives the signal back. Okay. I actually joined the class late, right? I'll show the image. I actually explained it. See, this is how one side is transmitter, one side is receiver. Okay. Whenever you send a pulse to the trigger, this will send the waves like this. Okay. Then it will like it strikes the object and it bounce back and it will go to the receiver. So whenever it receives the echo pin, the sensor will turn the echo pin high. Okay. Whenever it receives only, it will make it high. So what we have to do, we have to read this pin going high or low, correct? So trigger pin, you should supply the power to this. If you give 5 volts, it will start transmitting the waves. Whenever the waves are received, the sensor will make echo pin to go high. If there is no signal received, then it will be in low condition. Okay, got this point? Huh? So here trigger pin is output pin and echo pin is input pin, because echo pin is controlled by the sensor itself. Trigger pin, we have to give the power supply to trigger the sensor. So we have declared in the void setup pin mode here. Pin mode trigger pin as output and echo pin as inputs. So what we'll do is we have to trigger the sensor to get the waves, right? So what we are doing is we'll trigger in very like very fast and very like short period of time. So we'll get packets of waves, different packets of waves. So here what we are doing is digital right trigger pin low. Initially we'll make for 2 microseconds as low. Then for 5 microseconds, I'm making the trigger pin high. So in this 5 microseconds, for 5 microseconds, my sensor will start like generating the waves. Around 4 to 5 waves will be generated. So those wave will travel, and again like after 5 seconds it will stop generating the waves because I've turned the trigger pin low. So it will stop the waves generation. Only some packets of waves is generated that will travel, and it will come back. So we have to read this echo pin if the like whatever wave we have sent, if it is receiving or not, we have to read, and how like for how long it is receiving, we have to check that, right? So we have function called pulse in. This function will read whatever condition we mention. So here we have to give the pin. So I'm giving echo pin to be read. So pulse in will read the pin. So I'm writing high. It means whenever the pin goes from low to high, it will start the counter. And if it goes from high to low, it will stop the counter. So when for how much duration the pin is going to be high, we'll read that and we'll store in the variable called as duration. It will be in microseconds because we are like turning on off and on for microseconds, right? So the waves received also will be very short. In microseconds will receive, or it may be more than that also, not in microseconds only, but usually it will be in microseconds. So that duration we will multiply with the speed of sound. So speed of sound is 340 meter per second, but we need centimeters. So we will convert that meter per second into centimeter per microseconds, and so that we'll get this centimeters. So by using the centimeters, like whatever condition we want, we can make like if it is less than 30 centimeter, what I'm making is I'm thinking that less than 30 centimeters is a danger for me. So I'm making the buzzer to go high for indication, and also red LED to glow high. If it is less than 50 and above 30, what happens is I'll only indicate red LED that there is bit danger, not that much. So only red LED I'm turning on buzzer to go low, and green LED also to go low. If it is more than 50 centimeters, like object is far away from the sensor with 50 centimeters or above that, I'll show it as green, saying that it is safe. No, like object is there, something like that. Yeah, I didn't record or what? It was recording, right? Is it recording? Hello.
ರೆಕಾರ್ಡ್ ಆಗ್ತಿದೆ ಮಗ.
Okay, where this Lalit went? He asked me and is not responding now. And you should like turn off your camera, Yashashwini. Your camera is on. Yeah. Lalit, is that
Sorry, sir.
clear? Lalit,
Yeah, bro.
is that clear? I explained once again. It is like
Yeah.
third time today explaining this code.
I got it. I joined late. That's why.
Yeah, I got that. Like I was checking. You were not there in the initial stage. So we'll go
Yeah,
with
bro.
next sensor.
ಮಗ ಈ ಕೋಡ್ ಶೇರ್ ಮಾಡಕ್ಕಾಗುತ್ತಾ?
Yeah, I can share this code. I'll share this code later. At the end of this session, I'll share this. Okay. Now we'll look into PIR sensor. Okay. So what I'll do is I'll just like copy all this code and make a new functions. Here we can make any number of functions, and we can call that function whenever required. So what I'm doing is I'm making ultrasonic. So I'm making a function called as ultrasonic, and I'll remove this from loop. Okay, what happened? Yeah. And I'll paste this in this function so that my code looks, oh, what happened? Yeah, my code looks clean and it will be easy to readable. Like if there is some issue with the ultrasonic, I can come to this function and I can just check this section of the code. If it is in loop, so all the code will be in loop. I cannot detect my errors if something goes wrong. So I have to call that function in the loop also, so that from the loop it will redirect to this function. So yeah, so I'm calling ultrasonic function first. Then now like for function declaration, we have to give void So void ultrasonic, then that function brackets, you know, right, how to declare a function. So that thing I'm using here, that's all. Yeah, so now we'll use PIR sensor. Anyone knows about PIR sensor? Who can say about it? Like, you can speak few about this sensor if you know. Anyone knows, or should I explain that sensor a bit? No response. Hello. Hello. Okay, Lalit is not there only. Fine. Okay, so PIR sensor. We will use this PIR sensor for motion detection. It means if there is any movement in front of this sensor will like generate a signal. Okay, you can see two red LEDs like glowing in this sensor. It means like some motion is detected. If I shake this object, right, this red LEDs will glow for few seconds. So okay, it is taking too much time. Why is this not turning off? Okay, so I'm not connected this like ground power pins, right? So it is taking a lot of time to turn off. So if we power up and all, like this is a software, so it is showing actually without powering also. But in hardware, it doesn't show like this. If you don't connect, you have to connect and then only like it will get the power and it will work. So if like if there is some movement of the objects, this red LEDs will glow. If there is no movement for a few seconds, then only it will stop this sending the signals. So what we'll do is we'll first we'll first connect. We'll do wiring thing first. So this like sensor has three pins. One is signal, one is power, and ground. So I'll connect the power with 5 volts. So I can take from here. Okay, oh sorry, stop the simulation, then only wirings will work. So I've connected the power as red. So I have to ground this. If you don't ground, this will not work. So I'm grounding this. So first we'll give the power supplies. Then we have signal. Signal means whenever there is a motion detected, this pin will go high or low. It is sending some signal. So what we have to do is we have to send the signal to the microcontroller so that we can read this pin and we can take some action on this. So I will connect. So many pins are left out. So I'll go with pin number 3. Okay. So okay, I'll give this some orange color. Okay. Cannot the orange. We'll give some purple kind of thing. Yeah. So we have the wiring is so simple. We have only 3 pins. One is VCC or power, one is ground. So both are connected to the power and ground, and only one pin which is like sending the signals. So we have connected that signals to pin number 3. So this is a sensor. Obviously, this will be an input pin because the sensor will generate some signal, right? So as defined PIR, I'm like declaring to which pin the PIR is connected. The pin number 3 is connected with PIR. So I'll use as defined, not the constant. You can use constant also. I'll use this as defined only. So now we have to set up the pin as output or input. So I'll just comment down as PIR. So this is for PIR. This section of code will be for PIR, something like that. So pin mode. Okay. So pin mode PIR, comma, it is an input pin. So microcontroller should read this pin. Whenever there is a movement, the sensor will make this pin as high. So I should read if it is going high or low. So I have made pin mode as high. Then what I'll do is here, we have to actually read this pin, right? So we have function called as digital read. Okay. So initially I'll make some variable. like in values. Yeah, we can write direct also if like okay. This will be confusing you. So I'll make some variable like int signal. Okay. So I've declared one variable int signal. So signal will be equal to, I have to read this. Signal will be equal to digital read, not write. Here it is read because this is an input pin. You have to read this pin. So it is digital read which pin. So I've declared as PIR. So PIR pin, comma, what you should read. Either you should read high or low. So whenever it goes high, I should read that, right? So I'll make it as high. It will read whenever that pin goes high, it will start reading. Okay. Okay, I missed earlier.
It's mine.
So now I will write some if condition. If signal goes high, like if signal goes high, this pin will be high. If it is low, then it is low. 1 second. Something I did wrong. Yes. 1 second, guys. One second. Okay, just digital read signal. Yeah, not high. Only the pin which you have to read, you can read. Like if it is goes high, then the variable will be high. If it is goes low, then variable will show it as low. So like if it is high, then the function will have some value. If it is 0, then it will be having 0 value. So if signal, I can write condition like this. If signal, then there is some movement, right? What I'll do is, if there is some signal, I'll start the buzzer. Okay, what happened? Yeah, so if signal, it means there is some movement in front of the PIR sensor. What I'll do is I will turn on the buzzer so that it is saying that something is there in front of you, something like that. Yeah. So digital write. So I'll write to the buzzer pin. So buzzer, comma, high. Sorry, high capital. Okay. So else we have to raise else condition, because if we don't write else condition, then it will never turn off. If the condition is satisfied, it will go high, then it will never come back low. So you have to write else, the pin should be low, right? So write pin is buzzer pin, so buzzer, comma, low. So now we can see the PIR sensor working. Digital, okay, where did I write something? Okay, here digital read r stop. Okay, so yeah, circuit is working. So if there is a movement, see the buzzer start glowing. You can see buzzer is glowing. Okay, it will stop after few seconds. Okay, it is now. Oh yeah, it got stopped. So minimum of some, like here it is 1 minute. The timer is going in terms of like milliseconds. So for a few milliseconds only it is going on, but we are seeing for many seconds because the like simulator time, we have to just check the simulator time for how many seconds it is going high. So if I move this at 400, I move, so it will go off at okay for almost 1 second. Like for 1 second it was high. So if there is a movement, then it will be buzzing uh, mm, until like the object stops moving, it will be buzzing itself. I'll stop this. So this is how PIR works. Got this right? If there is any object moving in front of it, it will generate the signal. You can use some buzzer or for any conditions, like for any applications you can use. If there is movement only, it will generate the signal, and those generated signal you can use for some outputs like buzzer or LEDs, whatever. So this is all about the PIR sensor. It is so simple, only 3 pins. Only you'll read this pin if it is going high or low by using if statement. If signal means if it is going high, then this condition will go like signal will have some value, which means it is true, right? If it is a low, then signal will have a value of 0. If 0 is false, so it will go to else condition. So this is how the if statement is working. Any doubts? Anyone? Okay, only phone numbers. Any doubts? Wasim, clear or any doubts? Hello. Respond, guys. Hello.
Yes, it's clear.
You're completely clear. If any doubts, you can ask. Any doubts? Completely clear. Others?
Yes, we can continue.
We'll look into this gas sensor today or tomorrow. It is 3:15. You people wish me to do this gas sensor, then I'll do. What will say? I'll show some few things about the serial monitor. So in the serial monitor, not only like variables, you can also print something like this, or like you can print the strings also, like serial dot print. So I have to print like this values. If I run this code and if I check the serial monitor, okay, 1 second. Okay, so I should remove this line. For now, I'll remove this line and run. Yeah, if I like see, this is showing 139, but we don't know what is 139 because we have so many sensors here. We don't know what is 139 it is showing. So what we can do is to make it readable, we can use some strings and we can show it as like centimeters. Where is the code? 1 second. Okay. Yeah, so I declaring strings will be in double quotes. So double quotes centimeters. If I do something like this, now if I run, you can see like this. So centimeters colon 137. It means that centimeters 137 or 138. If I change the value also, you can see centimeters is 94. So you can write anything, even like if I move this sensor, right? I'm not like printing anything. So I'll print something if there is something. Yeah, here I can write something here, or like serial dot print. Print someone is here, something like that. Someone is here. Okay, so like we can check in the serial monitor. Yeah, like if I move this thing, sorry, if I move like this thing, See, someone is here, someone is here. It is showing. I didn't use print ln, so it is showing both in the same line. So it is showing someone is there, someone is here. If I use print ln, then it will go to the new line. So now you can see what is the use of print ln. So normally it is showing centimeters only. If I move, you can see someone is here, then centimeters in the new line. Someone is here in one line and centimeters in other line. So println is used to like print in the next line. So this is like serial thing. Like you can print anywhere, anything you want. You can just debug your code by using serial monitor. If something is working wrong or you're getting wrong values, you should know, right? In hardware, you cannot see what values you're getting. So what you should do is you should use the serial monitor and you should print everything, whatever you want to be printed, right? So that you can see the values, what the sensor is giving, how much I'm getting, and what conditions I can apply. To know those things, you have to use the serial monitor. So to use the serial monitor, you should always write this code in the setup that serial.begin at baud rate, whatever baud rate you're working with. So if you don't write this line and if you write the serial.print, it doesn't work. You have to initialize the serial monitor first by using serial.begin. Then only you can use this thing like serial monitor. Got this right? Clear with the serial monitors, how to use them in wise of strings, like how to print the strings and then with the variable value. To print the variable value directly, you can write the variable as you do in the Python, right? Print like some x, print x. If you give the value of x will be printed, right? So same here. You can write the variable directly, then the value will be getting printed. So you people want gas sensor today or tomorrow?
Tomorrow.
Tomorrow. Yeah. So now we can take up some questions. Any questions related to this or out of the box? Also, no issue. You can ask. Is there any questions like in terms of wiring and all? Or some like if you will be having doubts like how to connect this pin to there only, something like that. Initially we'll be having those doubts, then when you get used to these things, you'll start understanding how to use which pin where. So, any doubts? If there is no doubts, then I'll end this session. Wasim? Any doubts? You want to ask anything like any sensor thing or anything? You have any doubts?
ಇಲ್ಲ
Hmm?
ಇಲ್ಲ ಮಗ ಕೋಡ್ ಶೇರ್ ಮಾಡು.
Yeah, I'll share the code. You don't worry that. I'll send other thing like connections or any other things if you want. No doubts, sir. We'll end this then. So we'll continue tomorrow with servos and all. In the next class, we'll be continuing with servo motor. Then if we'll check what all we can use. We have gas sensor in the way, right? So we'll use the gas sensor and use the servo. And we'll end this basic like playlist. Okay, guys, we'll end up.